Okay, hello everyone, welcome. Can you hear me?
Yes, sir.
Okay, just wait. We're waiting 5 minutes, then we'll start. Okay, so we will start today's session. So basically, today is our fifth number days, and I hope all of you already get all of previous recorded video class and also get the practice code. So after completing the 3 hours live session, then we talk about the problem solving for the previous classes. Okay. So basically today's session I try to discuss about that air quality monitoring, how we can easily monitor the air quality parameters, different types of air quality parameters such as nitrogen dioxide, sulfur dioxide, formaldehyde, or methane, or aerosol optical depth, or particulate matter 2.5. So this type of gases, how we can easily monitor using remote sensing technique in Google Earth Engine. I will try to explain all of those. So let me share my screen. Okay, can you see my screen?
Yes, sir.
Okay, thank you. So let's go. So today's session we discuss about this type of topic. So first of all, air quality monitoring, all of parameter, as well as we discuss about that how to download air quality parameters time series data in CSV file format in Google Earth Engine, and air quality monitoring time series chart, how we can easily calculate. We also discuss about that, and also how to calculate the total emission of any gases. I will show the example for nitrogen dioxide, but you can also apply it for other gases also. And we also discuss about that aerosol optical depth, and also discuss about that particulate matter 2.5, how we can easily monitor. As well as today's session I discuss about that ArcGIS, mainly ArcMap tool, how we can easily use to create the map after downloading the GeoTIFF file format from Google Earth Engine. as well as we also discuss about that accuracy assessment of air quality monitoring map. Suppose you just create the map, so now we want to check what the accuracy about that. Okay, so for checking the accuracy, we just need to import the ground truth data, then we just compare the relation for the ground truth data and satellite data. Okay, so I will show you this process also. Then how to extract the points pixel values for a specific geolocation. Suppose you have some specific geolocation, latitude longitude value. So now further this type of value we just import in Google Earth Engine, and you want to extract the point pixel value for this type of geolocation. So I'll show you that how we can easily use this type of things, and how to check the trend analysis. So basically, what is the trend of air quality parameters, it will be increasing or decreasing. So this type of things I also try to explain about the trend analysis, and how to apply the linear regression model in Google Earth Engine. We'll also discuss about that. So let's go one by one. I try to explain all of topic. Okay, let me open my slide. So if you check, this is the map, nitrogen dioxide and methane gas concentration map. So this type of map we are just simply use here Google Earth Engine to download the GeoTIFF file format, and further this GeoTIFF file format just use the ArcMap and create this type of map layout, or add the legend, or add the north arrow. All of those we try to add in ArcGmap tool. And this is another map, nitrogen dioxide concentration year of 2020 January. So after downloading the GeoTIFF file format, we simply add this type of things. And we also just make the classification also. Suppose different time period, we can just make the classification, very low, medium, high, very high. Okay, so this is another way. So just download the data from Google Earth Engine as a GeoTIFF file format. Further this type of classification, we are just use the ArcMap or QGIS software. And air quality monitoring using Sentinel-5P Propomy, this dataset we are just use. And this dataset mainly focused on air quality and composition, climate interaction with main data product, ozone, nitrogen dioxide, then sulfur dioxide, formaldehyde, aerosol, carbon monoxide, methane. So this type of gases we can easily access from here. And if you check, this is the link about that. So you can simply visit the link, then we can easily get all of dataset for Sentinel-5P Propomy dataset. So, or if you want, simply visit the code editor. Simply go to the code editor. From the code editor, we can also access the dataset. Just click on the browse data catalog, and then you can easily find out all of dataset. Click on the Sentinel. Mainly Sentinel-5P Propomy, this dataset. So here again, so you find out all of data such as aerosol index, cloud, or also carbon monoxide data, formaldehyde or nitrogen dioxide, ozone, as well as sulfur dioxide, methane, and all of data we find out the two types data. Here you can see one is the offline data, another is that
sorry, sir.
Yeah,
We
please.
We cannot see screening.
Oh, just a minute. Yeah. Oh, thank you. Just a minute. Okay, so now I hope you can see the screen. So here you can see, find out this type of data, nitrogen dioxide, ozone, all of data you can easily get, and all of data we find out the two types data, offline data and near real time. You can see offline and near real time. Offline and near, so only methane is only offline available, but all of data you can see sulfur dioxide, we find out the near real time and offline. So near real time data is more update data. Okay, so you can see it as available from 2025-04-25. Okay, 25 April we find out the data. So this is the last update time period. So NRT or near real time data give you the more update data. Okay, but when you work with offline, suppose you can check, just click on the offline. So offline data is not more update, so we find out that you can see 23, okay, 23 April. But when you work with the near real time, then we find out the 25 April. So two types that we find out, every offline and near real time. Also you can see this is the offline and near real time. Okay, so when you work with near real time analysis, then try to use the near real time data set. So in this case, suppose I want to work with the nitrogen dioxide, just click on the nitrogen dioxide. So now you find out this type of data. This is the offline nitrogen dioxide data, and it revisit interval 2 days, mainly temporal resolution. You find out the 2 days, and this data set is available from 2018 06/28, from 2025 04/16 April. We find out the data because it's offline. But when you find out the near real time, you also find out the more update. Okay, more update data we also find in here. And this is the information, this is the pixel size, this data. So this data set is that 1113.2 meters, and this is the description about this data. Okay, so now I want to use the data and monitor, suppose, nitrogen dioxide density. Okay, and if you check the different types of band we find out in here, so this is the nitrogen column number density, and this unit is the mole per meter square. Also tropospheric nitrogen column number density, stratospheric. Okay, so different phase of atmosphere we also find out. But when you monitor the density, we are just use this column, nitrogen number column number density, for nitrogen dioxide density. And if you check, this is the unit mole per meter square. We can also convert the unit in micromole or ton per meter square. So further I will show you that how we can easily convert the unit. So let's go try to use the data. So first of all, just simply copy the snippet ID from here and then paste in a code editor, then give a name, variable name. Suppose I put the name is that dataset. You can put any name. So now I simply import my dataset. So this dataset just need to filter. Okay, so this dataset just need to filter. So first of all, just select the specific band, which band you want to work. So this image collection have lot of band, but I want to focus on the density. So just copy this band, nitrogen number, column number, density. Just copy this band name and paste here. Okay, after that, just simply filter the specific time period. So this data set is available from, you can see this is the time period. So just I simply filter. So I want to need the data, suppose year of 2025, 1st January, from, suppose year of 2025 January, suppose 15 January. Okay, after that you need to import your study area. So you can simply import your own study area from the asset tab. Okay, just simply import your study area, or if you want, you can simply take the study area from this dataset FAO. It provides the level 2 dataset. We find out in here level 2. You can see this is a second level administrative area. Just I import, and then I filter my specific boundary from this dataset. Just take a variable. Suppose I put the variable name is RY and call this table. I want to filter. How I can filter? Earth engine dot filter equal. So what's equal what? So we can easily get this information from here. So I choose the administrative level 2. So if you check it, the table schema. So you find out, you can see administrative level 2. Okay, just copy and paste here, and then put the name. Suppose I want to monitor the Los Angeles. Just I put the name, or any level 2 study area. Just simply put the name. Then we can easily get this boundary. So now from this dataset FAO. So from this dataset, it provides the level 2 administrative level boundary. So from here, I just simply filter Los Angeles boundary and then store it in the RY. Okay, and I need this data for this RY. So if you want, you also visualize this boundary. Suppose I want to add the layer. So just use here map.addLayer function. map dot add layer for RY. Okay, and also focus, suppose map dot center object or your given study area RY, zoom level suppose 10, just on the code. So now you find out this type of boundary. Suppose I want to monitor the nitrogen dioxide density between this time period for this boundary. Okay, so I just simply take this boundary from the level 2 administrative dataset FAO. So it provides the administrative level 2 boundary, and I simply choose the Los Angeles. If you want, you can also import your shapefile. Okay, and further you can also easily import your own boundary shapefile from here. Okay, there is no problem. Okay, so after that, if you want to check, suppose how much image is available after filtering, and also use at the filter bounds function. So now it intersecting only for your region of interest, so RY. So now let's go try to check how many images we find out in this collection. So print this data set, use at the size function and run the code. So now it's computing how many images we find out between this time period. So we find out the 199 images between this time period. I find out. Suppose this is my image collection. Okay, so now I want to use this image collection and make the time series chart for this boundary. So then I can easily get the idea which day it provides the high density of nitrogen dioxide. We can easily find out. So let's go try to make the time series chart for this using this image collection. So for the time series chart, we already use this function UI chart image dot series. So just simply search here UI dot chart dot image dot series. So this function we have to use in here. So now in this time already I make the image collection 199, and this image collection is stored in the data set. Just copy the data set and paste here. Then region, it's my shapefile variable name. So shapefile is stored ROI. Okay, this variable ROI is stored the Los Angeles boundary. So just I put the ROI in here. So now reducer, I want to calculate suppose average density for this boundary. So just use here EE dot reducer dot mean. So now it's computing average. Scale basically it's the resolution 1113.2 meter. So just I keep same 1113.2 meter. And X property default we are using system time start. System time start. So now we find out this type of things. So now whole things is stored in a variable. This whole thing just stored in a variable. Before the variable in var keyword, put the any variable name. I put the chart, and now print the chart. Just run the code. So now it create this time series chart. Yes, please.
Sir, what is this X property denote?
X property is denote about that your start time. Suppose I want to which time it will be start for start the chart. Okay, from which time. So we start the chart regarding the system time start. Suppose it start from 2025 1st January. The chart also will be start from 2025 1st January.
Okay, so it is always written as
Yes,
system time start.
Yeah. It always we find out this default. Use the system time start.
Thank you.
Okay. So we find out this type of chart. Here you can see, but this chart, if you check, it show the 0. You can see this value show the 0. If you check, it also all of value show the null value. So this is the one kind of common problem, because in this case this unit is the mole per meter square, and we find out the very less value for the mole per meter square unit. So that's why Google Earth Engine chart, it automatically show the round figure as a 0. But this type of place we also find out a value. Okay, you can see now it show the 0, 0, 0. All of those show as a 0. Okay, show the 0, but it have a value. Okay, because in this case it's a mole per meter square, and this value is very less, very less. So that's why Google Earth Engine show the round figure as a 0. But this type of place we also find out the value. Okay, suppose in the 1st January, what the density value of nitrogen dioxide, in 2nd January, what is the density value of nitrogen dioxide. But in this case it show the 0, because unit is the mole per meter square, and mole per meter square when I use it find out very less value, very less value. Okay, inverse 5 or inverse 10, this type of value we find out. So that's why it show the round figure as a 0. So when you face this type of problem, not only for the gases, also other gases, then try to convert the unit. So now it show the unit as a mole per meter square, but when you convert into micromole, you try to convert micromole per meter square, then you also find out the value. Otherwise you can see all of those show as a 0. Not only for these gases, also for other gases, suppose sulfur dioxide or methane or any gases. When you face this type of problem, try to convert micromole unit, then we can easily find out the value. Otherwise it show the 0. Okay, if you keep the mole per meter square, we find out the 0. So now how I can convert mole to micromole? So you can simply, okay, so I'll show you the formula. Suppose I simply search here mole to micromole, simply search on the Google. So you can see, if you simply multiply the amount of substance value by this number. Okay, so now if I just multiply with this value, then we can easily get the result in micromole unit. Okay, you can see 1 mole equal to 1 into 10 to the power 6 micromole. So this value, if I just simply multiply, then we can easily get the result in micromole. So let's go try to do it and convert the unit micromole and then check what happened. Okay, so now here I find out the total 199 images. 199 images. So I want to convert all of images. Okay, because this 199 images is a mole per meter square. Okay, so this 199 images I need to convert into micromole from mole. So let's go try to convert. So in this case I just use the concept of function. So I create a function. This function help me automatically convert all of images from mole to micromole unit. Okay, so let's go try to create a function. So how I can create a function? So for the function, just take a variable name. You can put any name. I put the variable name, suppose micromole dataset. You can put any name. Okay, so I put the function variable name micromole dataset, and then put the function keyword and put the element name, suppose img. Okay, and then use the curly bracket. So in this curly bracket, I need to define what is my argument. My argument is that I want to use the element and then multiply with the value. This value I want to multiply. So let's go try to do it. So just I return this element, multiply with this value. Okay, so now it just work only for the one image. So these things I want to copy and apply all of images. These things I copy and apply all of images. So for that we try to use here dot copy properties this element and apply system time start, which is indicating this time, and also put the system time int. Okay, so in this case, if you try to just use the function, so this is the function. So what the purpose? This function just convert unit mole to micromole, and this function you need to connect with your image collection. So I have total 199 image collection. So this is my image collection and this is my function. So this function I want to connect with the image collection. So for connecting, just use the map function. Just copy and then paste here and use here the map function. Just bracket start and also close the bracket. So now this function is successfully connect with my image collection, because this data set, it's my image collection and this is my function. Okay, so this function I successfully connect with my image collection. So now micromole data set I use and make the time series chart. So let's go try to just change it. I put at the micromole data set. So now let's go run the code. So now if you check the value, you can see we find out this type of chart. We find out that, so we find out 127.403 micromole per meter square. You can see the another 151. So now all of those showing the value. But previous time when you keep as a mole per meter square unit, then we find out the 0. So it's a common problem any particular gases, because mole is indicating very less value. Okay, so that's why it show the round figure as a 0. But when you convert into micromole, then we find out this type of value. So now you can see we find out all of value in here. Okay, and this is the function. When you use this function, you can easily convert into mole to micromole. Okay, so these things we can also represent also another way. Suppose in this case you can see I just take the another variable and create this function and also do this type of things. But if you want, you can write the code another way. So I'll show you the both of way, then you can easily get the clear idea. Suppose I want to create the function in the same variable. Okay, I just use the same variable and create the function. So let's go, it also possible. So for that, just create a function keyword and put the element name, suppose img, same code I just write again, and return this image, multiply with this value, and then just use the copy properties for applying all of images. Copy properties, this element, and apply system time start to system time end. Okay, so now I create a function, you can see, but I want to keep the same variable. So that's why I create a function, and this is my collection. This is my collection. Okay, so for this is the function and this is the collection. So for connecting, just use the map function. So for that, just use a dot map parenthesis start and also close this parenthesis in here. So now just same variable, just I use the same variable. So in the same variable, this is my image collection and this is my function. This is my function, and I just use the map function for connecting. So this is the way to add the same variable. If you want, you can also use this way. Suppose you just create the another variable and create the function and connecting. So it also same. We find out the same result all time. So now I just use the data set, because I just convert into mole to micromole as the same variable. So if I just use it and then paste here and run the code, we find out the same result. Okay, so basically we write the function two way. If you want, you can take the another variable and write the function and connecting with the image collection, or if you want, you can just use the same variable and write the function and connecting using the map function. Both are the same. Okay, and we also find out the same result, you can see. So we find out the same result for this micromole unit. Okay, so now further, if you want, you can also add the other parameter, such as other option. Use here, suppose set options to add, suppose chart title, X level, Y level title. Okay, so for that, just make a dictionary, put the title. So I put the title, suppose NO2 time series. You can put any title name, and then vertical axis or v axis, put the title. Vertical axis represent it's a, I put suppose micromole per meter square, and then horizontal axis x axis, we find out, suppose put the title, it's a time, just put here the time. So now if I run the code, we also find out this type of option also added in our chart, but you can see we find out the line breaking chart. Okay, so it's not continuously line. Okay, it shows some breaking line in here, but it also some value. But when you when I add the chart title, x label, y label title, then we face this type of problem. So for what the solution about that? For solution is that you can just simply open interpolate argument. Okay, just open it. So how I can open the interpolate? So for opening that, just use here interpolate nulls. Not only for that, when you face any problem, this type of line breaking chart, just apply this interpolate nulls and open. For opening, just use here the proof function. So now if I run the code, so now we find out that continuous chart again. You can see we find out the continuous chart again look like that. So if you just click on here, we find out the chart look like that. Okay, so now based on the chart, I want to check the trend. Okay, so what is the trend for this chart? I want to check it. Suppose regarding this data, what's the trend, the day by day, it increasing or decreasing? I want to check it. So it's called the trend line chart. Suppose in this chart, I create a trend line. So from this trend line, I can easily get the decision for this Los Angeles between this time period. What the scenario of nitrogen dioxide density, it will be increasing or decreasing? I can get the decision about that. So for that, we also need to add the trend line. So let's go try to add the trend line. So for that, just use another argument, trend lines. We just put at the trend lines and then make a dictionary. So in this dictionary, we need to define about the trend line. So in this case, we find out only for the one line, you can see. So it's a one line, and one JavaScript represent as a 0. 0 is the first item. Okay, because sometime we can also find out the combo chart. Combo chart basically at the same time different line represent the different things. So for that, okay, just a minute. So now we can just simply put the trend line. Suppose 0 mainly just 1. Okay, it's only for the one line. Okay, so for that I put the 0. Suppose sometime when you add the more chart at the same time, then we also need to add the more 1 2 3 0 1 2 3 look like that. In this time it's just only one line, so that's why I put the 0. 0 represent the first line. So now I am to add this trend line for the 0. So put at the 0 mainly first line. And now we create a dictionary in here. So in this dictionary, we just put here the type. So first one is the type. What is the type of your trend line? So we find out the linear trend line or polynomial trend line or exponential trend line. So different types of trend line we also find out. So in this case, I want to apply suppose linear. Okay, I create the linear trend line. So now if I just run the code, then check what happened. So now we add, you can see we find out this type of trend line, you can see. Okay, so you can see we find out this type of trend line. So it show the low. Okay, find out that downward, you can see it show the downward trend line. So it means that for this time period, we find out that the nitrogen dioxide density is decreasing. Okay, for this trend, we find out this type of trend line. Sometime it show the upward or downward, so it depends on the data. Okay, so now these things we also represent better way. Suppose I want to add the color of the trend line. So for that, you can also add some other argument. Suppose just put here that color and put the color. Suppose I want to display is a red color. So now if I run the code, so now trend line show as a red color or any color you can easily choose from here. And after that, if you want, you can also add suppose line width. Okay, suppose for the just put here the line width. Suppose I put the line width is the 3 pixel, put the 3, run the code. So now it also increasing the width of line. Okay, or you can also put the more. After that, suppose I want to put here opacity. If you want, you can also decrease the opacity of the trend line. So for that, just use here the opacity. I put the opacity, suppose I put suppose 0.2, run the code. So now this opacity is also decreasing. So now I can see find out this type of opacity. Now it also decreasing the opacity. And you can see there is no legend. This chart is not show the trend line legend. So I want to add the trend line legend also. So for that, just use the another argument. It's called the visible in legend. Okay, just open, use the true. So now if I run the code, so now it also added the trend line legend also. So you find out, you can see this type of also it show the legend about the trend line, and this is legend of the time series chart. Okay, we find out the trend line and also find out the time series chart about that. So now we find out this type of trend line. So these things you can also apply for any other time series chart. Suppose you make the NDVI time series chart. So now you want to check what is the trend line about that. So just apply the same code for trend line analysis. Just use the same things. Okay. So this is the trend line we can find out in here. Look like that. And if you increase the time period, suppose I want to check it for year of 2000, suppose 24, from 2024, suppose December, I check for the 1 year data, December 31. Okay, just run the code. So now we find out the data for 1 year, 1 year data, and also create this trend line. What is the trend for that for 1 year? So you can see find out this type of chart look like that. So now you can see if you try to check, now you can see it show the upward. Okay, so for that, when you just increase the time period of your data set, then we find out that it also increasing, we find out the upward about the trend line. So it means that it increasing the density of nitrogen dioxide, we find out look like that. Okay, so you also try this type of trend line for other data set also, and then check what happened. Okay, so now this is a trend line. Now I want to visualize the map. Suppose I want to visualize this map and check where the high density of nitrogen dioxide, where is the low density for this study area. We try to visualize it. So for that, just suppose map I want to add in here. Just take a variable. I put the variable name, suppose mean NO2, and I just call the data set. Just copy this data set and then paste here. And now I want to reduce it. So I have total, you can see for the 1 year, we find out that 5150 images. So now I just calculate the average pixel from all of images and clip with my study area. Study area mainly ROI. So now display this map. Use here map.add layer and call the mean NO2. Just copy and paste here. Okay, and run the code. So it shows this type of white color. Further, we'll also try to add the color. So for the color, if you check the dataset information, there already provides some color code. You can see, just I copy the color code from here and then paste here to add my map. Just paste. Okay. So now just need to change the mean and max value. So this mean and max value I can easily find out from this layer. Just click on here and stress, suppose 98%. So now it automatically provide you that mean and max value. Then further just use it. Then you also find out the more better visualization. And this visualization basically 0 and 0.002, it's just show the mole per meter square. Okay, but in this case we already convert the unit micromole, so that's why we just use it to get the better visualization. Okay, just I paste here and also copy and paste here. Okay, so now further copy this variable name and paste after this variable name, and then put here layer name. Suppose I put it's a NO2 map. Just run the code. So now if you check, we find out this type of result. So basically this type of red color indicating about the high density of nitrogen dioxide, and this type of black color, it's indicating about the low density of nitrogen dioxide concentration. Okay, so now we find out this type of map. If you check the pixel value, suppose just click on the inspector tab and click on this place. So now for this coordinate, we check what is the value of nitrogen dioxide density. We find out the 249.84 micromole. If you check, suppose click on here, this type of black color, it's indicating about the low density of nitrogen dioxide. We find out the value 78.34. Okay, so we find out that this zone, we find out the high density of nitrogen dioxide, and this the result year of 2024. Okay, so you can also change the time period and visualize that result for other days or annual or monthly, and you can also create the annual time series chart and also create for monthly time series chart. So I already show you that how we can easily make the annual time series chart or monthly time series chart. So you also try to use this type of data and also make the time series chart for annual or monthly, and also check the trend for the annually and also check for the trend for monthly. Okay, we also check. So sometime you also face the problem for the time series chart. Suppose sometime when you work with the big study area and you create the time series chart, then we face some problem. Suppose it show there are the lot of pixel, so that's why it's not work. Okay, we face this type of problem. So that's why we need to apply to directly download the data. Okay, suppose this data without chart, I simply download the CSV file without chart. So CSV file we can also download it from this time series chart, download the CSV, but without creating the time series chart, directly I download the time series data. So let's go, I will try to show you that because it's very important. When you work some study area, you don't create the time series chart. It show that there are a lot of pixel, so that's why chart is not created. So for that, we also need to learn about that, how we can easily download the data without creating the time series chart. So let's go, let me show you that process. Suppose in this case, I want to apply these things for the big study area. Okay, simply change my study area. Suppose I want to focus, suppose whole Bangladesh boundary, then check what happened. So just I simply comment this 2 line, just comment, and I put this variable name as a ROI. Okay, ROI basically it stored the whole Bangladesh country boundary. Okay, so now if I run the code, so now this result appeared for whole country boundary of Bangladesh. So whole country boundary Bangladesh, what the scenario of nitrogen dioxide density in year of 2024 we find out, and also create the time series chart. Sometime time series chart cannot be created when you work with big study area. Then we try to apply the another solution. We just download the data directly as a CSV file. So it look like that, okay, because in this case we also need to change the mean and max value for the Bangladesh boundary. So let's go try to change it. Just click on here and I simply stressing again, suppose 98%. So now it automatically show you the range for the study area of Bangladesh. Further, if I just use it, then we also find out the more better visualization. So just copy this. Yeah, any question, please?
So why do we use this stretch function?
A
And
stress
what is the
function.
difference between 98% and 1
Okay.
sigma and all things?
Okay. So this stressing is one kind of data visualization process. Suppose if I just use the 98%, then this data for my study area, this data, it stress is using the different types of statistical equation, and it automatically show me the range. Okay, when I put the 90%, then it just 90% stress my data set and automatically show me the value. But overall 98% it look more better. If you want, you can also use the 90% or 3 sigma 1 sigma, then it automatically show the value. Okay, so it's just one kind of stressing process. And when you download the data, suppose I just download the data for Bangladesh boundary, so then it automatically show you mean and max range in the ArcMap or QGIS software automatically, which range is more perfect for your data. It automatically show you. Then further we also use it from here. Okay, but in Google Earth Engine platform, for stressing we can use the different level of stressing. Suppose if I just put the stressing level 1, you can see what happened. So it calculating the stressing 1 sigma for my data set and automatically show you the mean and max range, and depend on the range we find out the visualization. Now you can see we find out the 61 and 32 93 point something. If I just use at the 90%, so now it automatically computing this value using the stressing level 90% and show me this type of range for my data set, for my boundary in Bangladesh data. If I put the 98%, then it automatically change the range. You can see this range. So now it computing the stressing level 98% for my data set. So it automatically use the statistical function and compute this type of range. So further, this type of range if I use, then I find out the more better visualization. Otherwise, I put here this. Yeah. Please.
How can someone decide which stretch function is better? Like
okay, you try to check it randomly. Try to check randomly. Suppose you just try to add 98% or 90% or 3 sigma. So which label provide you with a good or better visualization of your map? So if you check here, so now this map is not look more better. Okay, you can see it show all of place show as a black color. Okay, we find out only for this, and you can see this place is not showing the red color. Okay, this place is not showing the red color, but in this map I also use the red color. Okay, so that's why I need to increasing the stressing level. Okay, if I just you increasing the stressing level 98%, now I apply these things. So now you can see what types of map I find out. So now it including all of color. So you can see it show the all of color. So we find out the black color, we find out that blue color, we find out the I think it's a pink color, or this color, green color, yellow color, red color. So now this map is the combine all of color and create this type of visualization. But if I put the stressing level 1 or stressing level 2, then this data is not visualized all of color. So you try to check it for your data set, for your map, which level provide you the more better visualization. Okay, then use it in Google Earth Engine. But when you download the data, suppose I just download the data as a GeoTIFF file format and import in the Google Earth ArcMap or QGIS software, then it automatically show you the mean and max range. Okay, then we can also use tracing also in Google ArcMap or QGIS software, but it show you the better visualization, automatically show the mean and max range. Okay, so now you can see in this map we find out all of color, including all of color. Okay, which color I want to add in here. So we can find out this type of place is the black color. And if you check the value, suppose if you check when I stressing 98%, we find out the 56.93. So this type of black colors, it's indicating about that greater less than equal 56.93. So if you check the value, suppose if I just click on here and click on this value, so it show the result greater than equal 56 or less than equal 56. Less than equal 56 we find out in here for this type of black color pixel. So now let's check. You can see we find out that value for the black color pixel 57. Okay, so you can see almost similar. Okay, not much far difference. But when you check suppose this type of red color, so you find out that 192 or greater than 192. So let's check. So you can say 202. Okay, greater than 192. So greater than all of pixel show as a red color. Okay, greater than equal 192, all of value show as a red color we find out in here. And you can see we can easily identify this type of place, and also this type of place is the low concentration, and this type of place we find out the high concentration. Okay, so this is the map, but in this case if you check the another problem, it show this type of problem. We find out that user memory limit exists. So this is the common problem for the time series chart. When you work with big study area, then we face this type of problem. So that's the reason we also need to learn about that how we can easily download the data CSV, because chart is not work for the big study area. I can easily make the time series chart for the small study area, there is no problem. But when you work with big study area, then we face this type of problem. Error, generating chart, user memory limit exists. So for that, we need to create the CSV file. Okay, so let's go and try to create the CSV file and then show the result, export the result. Okay, so okay, let's go. Okay, so for the CSV file, when you download, first of all in the CSV file have a 2 column. Suppose if you check the one random file. Okay, suppose let me open. So as you can see, this is one kind of CSV file. It show this type of column, this system index, PM 2.5 data, latitude, longitude. So now in the CSV file, I want to create the 2 column. Suppose one column represent the date, another column represent the value. Is date, what's the value of nitrogen dioxide? So let's go try to create this type of column. So for that, I take a variable, suppose CSV, and create a function. This function I put the element, suppose image. So now I want to use this element img. This is my element name. I just use this element, and further I want to calculate the is day average value as well as also extract the date. Suppose 1st January, 2nd January, 3rd January. So now from this element, I extract the 2 information for the 2 column, date and also value, or time or value. So for first of all, just take a variable, suppose date, and use here img date, and I put here the dot format function, format. So in the format, we can define the different formats. Suppose year, then month, or day. This is the one kind of format. Or if you want, you can also put the default. Then it show that default. Okay, so I put the default format. Date format, I put the default. After that, I take the another variable, suppose stat. In the stat variable, I stored the calculating the average. So from the image, from this element, my element name is the img. Just I apply the function reduce region. Okay, this reduce region function I apply, and then compute, suppose reducer, and apply ee dot reducer dot mean. So now it computing the average value, and then put the geometry. Basically it's my shapefile variable name RY, and then scale is that 1113.2 meter. Okay, I define the scale about that. So after creating these 2 things, we just create a dictionary. So just take a variable, suppose dict. I put this dictionary variable dict, and put here the curly bracket, put the date, and also put here the date, same variable, keyword and key value, and also stat, also keep the same stat. Okay, just create a dictionary using this two variable, date and stat. So now what I return from here, so just I define what I return from here. So I want to return feature. Okay, feature basically it stored the information. So put here ee dot feature, and we already know about that feature is one kind of point line polygon, but in this time in this feature there is no information about the geometry. So put here the null, and after that set with the dictionary. So just put here the dict. Okay, so e dot feature null basically it's indicating about that there is no geometry information. It just only show the value and time. Okay, so let's go try to print, suppose print this. Okay, sorry, and now I create the function. Okay, you can say I create this function. So this function I need to connect with my image collection. I already make the image collection total 5150. 5150, this is my total image collection, and it is stored in my collection dataset. Just I copy the dataset and connecting with my function. So just paste here and use here the dot map function, parenthesis start, and also close this parenthesis. Just close this parenthesis. So now if I just print the CSV file and then check what happened, just run it. Okay, so you find out this type of problem again because there are a lot of data. So just let me check for first data. Okay, then we can get the idea. Just put the first. So we can find out the first item. So let's go, we find out, we can see properties. We find out that date. So this is the date and this is the stat. Okay, so let's go, we try to now export all of those as a CSV file. So for exporting CSV file, just use the function export table to drive. Okay, this function is simply use. And now first argument is for that collection mainly CSV, which stored all of value for date and stat, and then put the description. I can put anything. I put suppose CSV data, and then put here folder. Okay, you can put any folder name. So folder I put suppose GE, and then selectors or file format. Okay, so file format. So file format is the CSV, and then final one we just keep in here for selectors. Selector basically column name. Okay, you can see this is the column name, date and stat. So just I put here date and stat in the selectors. Date, and also put here that stat. So now if I run the code, our task tab will be running, and from this task tab we can easily download the data, time series data. So just run and also run. So it's very helpful when you face the problem to creating the time series chart, and when this type of problem occurred when you use the dataset for the big study area, then we find out the user memory limit exists, this type of problem. So then we try to download the data as a CSV file. Okay, so you can apply these things any dataset, not only for that, any dataset, any time series dataset, we can apply the same process to download the data in CSV. Okay, anyone any question you can ask me, please. Okay, now it's working again. So after that, we can easily open the data and also visualize this data. And when you export, same process for exporting. Suppose I want to export the GeoTIFF file format. So just use the code from the docs tab. People simply search here. Export table to drive. This function. So now first of all put the collection. So collection, sorry, table. Okay, export not table. Export image to drive because we export the image. Just remove it. Export image to drive. So now we can see first of all is that image. So which image you want to export? I want to export this imagery, and this imagery is already stored in a variable. Just find out this variable name. Which variable stored this imagery? So just find out this variable name. So in this case, if you check which variable stored this, so we can check mean NO2. So this variable stored this map, because when I add the layer, we find out this map. So now this map is stored in this variable. So just I copy and paste here. Further apply the description. You can put anything as a description. Suppose I put it, it's a NO2 map.